Welcome back. Problem 3.30. So in this problem, it is given that while exact distribution of shearing stress in hollow cylindrical shaft is shown in figure 3.30. So this is figure 3.30a. An approximate value can be obtained for tmax by assuming that stress are uniformly distributed over area A of cross section as shown in figure 3.30b. So this is B. And then further assuming that all of the elementary shear forces acts at a distance from O equals to the mean radius Rm is this of the cross section. The approximate value of T naught is equal to T over ARM, where T is the actual or applied torque. Determine this ratio Tm over T naught of the true value, and also find T naught over T naught T max over T naught value for C1 over C2, which is equal to 0.75, and this. So we will write, I have written given data. So initially it is given that maximum shearing stress is equal to exact distribution of shearing stress in hollow cylindrical shaft and as shown in figure 3.30. So this is the maximum or actual shear stress distribution in the hollow shaft. Now it is given that the approximate value of tau max can be obtained by assuming that stress are uniformly distributed over area A as shown in this figure. So this tau max can be obtained by assuming that this T naught is uniformly distributed over this area. Also in question it is given that mean radius is equal to this, and this T naught is equal to T naught is equal to T over A into Rm, where T is applied torque. So what we have to find is we have to find this ratio tau max over T naught for C1 over C2 value equals to 1, 0.95, 0.75, 0.5 and 0. So let's move and solve this problem. So first it's as for a hollow shaft, because the shaft shown above is hollow shaft. So for a hollow shaft we know that maximum shearing stress is equal to T into C2, because C2 is the outer radius, divided by J, and J is the polar moment of inertia. So T into C2 divided by polar moment of inertia for hollow shaft is equal to pi by 2 into C2 4 minus C1 power 4. Also it will be equal to, this 2 will go upward, so it will be 2t into C2 divided by this C2 power 4 minus C1 power 4. Okay, so tau max will be equal to 2t into C2 divided by this C2 over C2 power 4 over C power 1 will be equal to C2 square minus C1 square into C2 square plus C1 square. So again you can see that and there is a pi as well. Clear? So there is a pi as well. Now we know that area of hollow shaft is equal to pi into C2 square minus C1 square. So here this term will be replaced by A. So we will rewrite the maximum shearing stress will be equal to 2t into C2 divided by area into C2 square plus C1 square. So this is the maximum shearing stress for hollow shaft. Now by definition, or by given that the T naught is equal to T over ARM. I will show you here. It is written that given T. So what we have to do is that we have to put the value of Rm. So A into Rm is C1 plus C2 divided by 2. So from here you will get T naught is equal to 2T over A into C1 plus C2. So this is the equation of T naught. I will write it again. This T naught is equal to 2T over A into C1 plus C2. Let this is equation number 1 and this is your equation number 2. And in given in a question we have been asked to find Tmax over T naught. So what we do, we will divide equation 1 by equation 2. So when you divide equation 1 by 2, it will be Tmax over Tmax over T not T, tmax over tau naught will be equal to 2T C2 over A into C2 square plus C1 square divided by 2T over A into C1 plus C2. Clear? So again you can see that this 2T and this 2T will cancel with this 2T and this A will cancel with this A. So we will left C2 into C1 plus C2 divided by C2 square plus C1 square, and that is equal to tau max over tau naught. Okay, now you have to divide numerator and denominator by C2 square. Clear? So what you have to do, you have to divide this by using C2 square and this also by C2 square. So it will have no effect. So tau max over tau naught will be equal to, this will give you C1 plus C2 divided by C2, and the below one will be equal to C2 square over C2 square plus C1 square over C2 square. And here there is this C2 will cancel with this C, so it will be this one. So if I simplify it, it will be C1 over C2 plus C2 over C2, and the below one will be equal to 1 plus C1 square over C2 square. Okay, so this tau max over tau naught will be equal to, this will be 1, this term will, this will cancel with this, so it will be 1 plus C1 over C2 divided by, this will be 1 plus C1 square. C1, if square, since square is common, so C1 over C2 whole square. So this is your required equation. Clear? Tau max over tau naught is your required condition. Let me check it also. So you can see we have find T max over T naught. Now we will put the different value of C1 over C2 which is given over here, and we will find the T max over T naught. So if I draw a table where we have been given C1 over C2 and we have tmax over T0. So when Cmax values are 1.0, 0.95, 0.75, 0.5 and 0. So when you put 1 in this equation, let's say this is equation 1. So put C1 over C2 is equal to 1 in equation A, we get T max over T naught will be equal to 1. You can see this C2 or C1 will be 1 and this will be 1. So 2 divided by 2 will be 1. So it will be 1. Similarly, you can put C1 over C2 in here. So you will get Tmax over T naught is 1.025. Same is the case, you have to put C1 over C2 in this equation A, you will get 1.120. Same is the case for 0.5, so you will get 1.20. And if you put C1 over C2 is equal to 0, so you will get tmax over T0 is equal to 1. So this is our required answer for different values of C1 and C2. I hope you have enjoyed this video, and if you haven't subscribed my channel, then subscribe it now.